Hey Algebra, just wanted to do a quick video talking about how to write an equation based on a graph that's been given to us. So we had 4 that I assigned earlier today, and maybe you're watching this the day that I assigned it. Maybe this is years from now, and well, hello, new students who have never met before but have met because you're watching the video. This is really geared to helping you see the type of equation you need to write, how to write it, and moving forward that way. So for this first one, we have a graph that is a V shape. It's pointing down. So in my mind and in your mind, what I'm hoping right now is as you're looking at this, you see the V shape, you're thinking about a particular equation or function that this is going to match to, all right? We can write down some notes. The notes being, let's see, this right here, this point is at -2, 1, 2, 3. And that's going to be kind of helpful, right? And then also, I'm going down 1 over 2, down 1 over 2. It's kind of like a slope, like these are lines. So this is going to be kind of useful information for us as we keep as we move towards writing the equation, right? So you can choose to do this as an f of x or y equals, if we do f of x, one thing that I know for sure, this is an absolute value function. All right, absolute value gives us the V shape. I have the vertex. The x value is a -2. That means the x here, this has to be a -2, so then this has to be a +2, right? I want, when this is -2 plus 2, that'll zero out, and that's the objective of this being a -2. And then the +3, that actually goes out here as the +3. This is always your vertex, which is kind of nice. Whatever zeroes out the absolute value, -2, and then the +3. From there, I know I have a negative because it faces down, and then I'm going down 1 over 2, 1/2. And now you've written the equation of that line. But, Mr. Mock, oh my gosh, I don't believe you. You're not really trustworthy. Oh, hurt feelings, that's okay. Let's talk about it then. This is supposed to be at 0, 2. So that means when x is 0, y is supposed to be 2. Let's check and see if that is a true statement, right? So then we could do is take the point and plug it in. So when f of 0, what happens? So it's going to be -1/2, absolute value of 0 plus 2 plus 3. Well, what's that going to equal? -1/2. 0 plus 2, last time I checked, 2. Absolute value of 2 is 2. -1/2 times 2 is -1 plus 3. Holy moly, look at that. When x is 0, f of x is 2. It works. It's amazing. This is so special. Okay? So we double checked it because it's always nice to double check. But you've written your equation, and that would be a good trick. Like after you've written the equation, pick a point that you see on the line, plug it in, and make sure it works. All right. So that was the absolute value. Now let's go to this one. I know that when I wrote this one or drew this one out, my students went, oh, no. But it's okay. It's actually not too terrible. When you look at this, this is a distinct shape, okay? This is a parabola, okay? When we're thinking about a parabola, that is a quadratic. That is something squared, right? And when we talk about the structure of a quadratic, right, that's going to be this x something squared plus something else. Always the squared. So you start by needing a vertex. 1, 2, 3, -1. 3, -1. So when x is 3, this is going to zero out. So that means I have to subtract 3. 3 minus 3 gives the 0. And then it's -1. That means I'm going to go down 1, -1. So I've got the start of this, but here's the problem. Here's the part that makes this tricky. The parent function of a quadratic, right, goes over 1, up 1, over 2, up 4, 1, 2, 3, 4, right? over 2, up 1, 2, 3, 4. But this one doesn't. So the parent function is different. This one's narrower, or more narrow. It goes over 1, up 3. It goes over 2, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But what does that mean, right? So if you think about it, it typically goes over 2, up 4. Well, what's 4 to 12? That's times 3. Over 1, up 1, over 1, up 3. What's, instead of going up 1, I went up 3. That's a multiply of 3. Multiply of 3 from the parent function. So what this is showing us is that the multiplier out front is 3. And now we've written this equation. Mr. Mock, I'm sorry, we've established that we don't trust you. Okay, that's fine. Then pick a point. 1, 2, 2. Plug it in. So 3 times what's 2 minus 3 squared minus 1. Well, 2 minus 3 is negative 1 squared. Negative 1 squared is 1. 3 times 1 is 3. 3 minus 1 is 2. And look at that, 2, 2. It works. We did it. Yay us. So now we need to move on because I'm already at 6 minutes and 25 seconds. And some of you went and looked at the time, and now it's not that because time continues. Here we are with the next one. Weird shape. I made a mistake there. Just bear with me. I have this, like, some of my students have called it an R that's fallen over. I don't know. Maybe. Maybe not. You always start with the starting point. Negative 1, 2, 3, 4. Negative 2. All right. Now, this is, I always see, you all say it's an R. I always imagine if I were to do this, it kind of looks like a square root sign, right? So this is actually a square root function. And when I'm thinking square root function, I go square root, I put my x in. How do I zero out a negative 4? Means it's got to be plus 4, right? Negative 4 plus 4 will make that 0. This y is always just outside the minus 2, so we're pretty much there. But then we have to think about our parent function. Our parent function, again, typically goes over 1, up 1, over 4, up 2, right? Because the square root of 4 is 2. So it's kind of like this. Unfortunately, it's bigger. Oh, look at that, though. It's like here, 1, and 1 is 2. 2 and 2 is 4. Oh, it would be like right here. 1, 2, 3, 1, 2, 3. We doubled it. Look at that. We're just doubling. Right? 1 to 1, 2 to 2, 3 to 3. So all we did was double from the parent function. So that means this is what it should have been, but because it's bigger, that means we multiplied it. We multiplied it by 2. Pretty sweet. Mr. Mock, you make it look too easy. I know, I'm sorry. But there's a process here. It's always the same. So when you see the graph, if you can connect it to it being this, and you can kind of envision the parent function, over 1 up 1, over 4 up 2, over 9 up 3, right? Because the square root of 9 is 3. Square root of 4 is 2. Square root of 1 is 1. But when I'm doubling it, that means it's going to be 2, 4, 6. Because you're multiplying this by the 2, doubling it up. All right, next one. And this is a step function. So this one's a little bit trickier. Okay? Now, step function means we have a line, we have this, we have this. This is all quite interesting. So what I'm going to do is, to help me out, I'm going to extend this line so I can kind of see what the y-intercept is, right? So I'm going up 2 over 1, 2, 3, 4. Oh, up 2, or up 1 over 2. Up 1 over 1, 2. Right? So that means my y-intercept for this one is going to be right in here. All right, so what's that going to be? 1, 2, 3.5. 1, 2, 3.5. And my slope is a positive 1, up 1 over 2. So my slope is 2, right? So when I'm thinking about this, this line, it's going to be y equals my slope of 2x, my y-intercept is plus 3.5, but now I need to do my range, and that's going to be x. It's an open circle, so x is going to have to be less than -1. Okay? So that's when x is less than -1. So I'm only using this equation when x is less than -1. Now when it's at -1, 2, let's see, the 0, 1, 2, I have this line. And that's, let's see, that's when y is at 1. So my next equation is y equals 1, but I'm only doing that from -1 to 2. And that's in no line underneath because it's an open circle, which means now I have to do this line, and I'm going to go ahead and do what I did last time and say I go over 2, up 1, 2, 3. So I'm going to go down 3, 1, 2, 3, over 2 is going to give me my y-intercept. Down 3, over 2. My y-intercept is going to be -1, 2, 3, 4. So now I can write my equation. I have my slope up 3 over 2. So y is going to equal up 3 over 2x, 1, 2, 3, 4, minus 4. And that's only when x is bigger than, or is 2 or bigger. So x is greater than or equal to 2. We're at 11 minutes and 42 seconds. One of my longer videos. But this kind of talks through the absolute value, what you're looking for, because then you can reverse engineer it now, right? Okay, -2 and go back. A parabola, a radical, and a step function. Okay, guys, I hope this video helps. Please bring questions. I'll talk to y'all soon. 12 minutes and 20 seconds.